Hello, good evening. So today we shall be taking up a discussion on the chapter of light in the class 10 NCERT book. So let's have a look. So today we shall be learning about the concept of spherical mirrors, and we shall be learning about the ray diagrams, and we shall be learning about the image formation by spherical mirrors. So let's start the journey of learning. So first of all, we have been hearing this word mirror. What is a mirror? A mirror is basically a highly reflective surface, right? Now, then you would ask me that what is a reflective surface or what is reflection? So, when a ray of light falls on a surface and bounces back into the same medium, this is known as reflection. So, when the ray of light falls on a particular surface and it bounces back into the same medium, then we call it reflection. If a ray of light hits a surface and it moves into the surface, into the other medium. So this is medium number one, say air, and this is medium number two, say water. So when the ray of light falls on the interface and it moves into the second medium, this is known as refraction. So I hope now you understand that if a ray of light falls on the interface of two mediums and it bounces back into the same medium, then it will be known as reflection. And if it moves into the second medium, then it will be known as reflection. And while moving into another medium, you will see that the original path of the light ray will deviate from its original path. The light ray will deviate from its original path, and that is called refraction. So I hope that you have understood what we mean by reflection and refraction. So now let's come back to reflection. So now you understand that if there is a surface which is highly polished, which is completely polished, then here the ray of light, when it is incident. Now let me tell you what is incidence. When a ray of light is falling on a particular surface, we call it as the incident ray, right? And when the ray of light bounces back after striking the interface, then we call it the reflective ray. I hope this is clear. And the point where the light strikes the interface, at that point, if we draw a line, an imaginary line, which is perpendicular, perpendicular means 90 degree, with the interface. This is called the normal at the point of incidence. And this point where the ray of light strikes the interface or the surface is called the point of incidence. I hope that we are clear, but for our better understanding, I shall be repeating it once again. So once again, let me repeat it from the beginning, that we have a surface which is highly polished. If the surface would not have been highly polished, what would have happened? Then the ray of light would have come, would have come, would have been incident at this point at the interface of medium 1 and medium 2. But because the surface is not polished, it's not highly polished, a large part of the light ray would have got refracted. It would have entered the second medium. And only a small part of the light ray would have bounced back or would have got reflected. Now, if the surface is highly polished, then the refraction will be minimum and maximum amount of light will be reflected back into the same medium. So I hope we have been able to understand. So there's a ray of light which comes. It is incident on the surface. This will be called the incident ray. Now, the point at which the ray of light or the incident ray will strike the surface will be called the point of incidence. Point where the incident ray is striking or the point of incidence. Next, after striking, the ray will get bounced back into the same medium and this ray will be called the reflected ray. And when we draw an imaginary line at the point of incidence, which is perpendicular to the surface, to the reflecting surface, it is called the normal at the point of incidence. And obviously, this surface will be called the reflecting surface. Right? And the angle, the geometrical angle between the incident ray and the normal at the point of incidence is called the angle of incidence. The angle of incidence and it is denoted by the letter I. It is denoted by the letter I. Next, the geometrical angle between the reflected ray and the normal at the point of incidence. Remember, whenever you are writing your answer or whenever you are mentioning it in your diagram or your exam paper, always remember to mention it as the normal at the point of incidence. Because there can be many normals. There can be a normal here also, there can be a normal here also. But here we are specifically talking about the normal at the point of incidence. So, this will be called as the angle of reflection. And it is denoted by the letter R. Hope our understanding is clear. Now, let us talk about some laws of reflection. Laws of reflection. So the first law of reflection states that I is equal to R, which means the angle of incidence is equal to the angle of reflection. This is a universal law. It will hold true at all times. So I will always be equal to R. And second, we come to the incident ray, the reflected ray, and the normal at the point of incidence will always lie in the same plane. It means that if you have a surface, right, incident ray, normal, and the reflected ray, so they will not be oblique to each other. They will lie in the same plane. The incident ray, the reflected ray, and the normal at the point of incidence will lie on the same plane. So these are the two laws of reflection. First, the angle of incidence will be equal to the angle of reflection. And second, the incident ray, the reflected ray, and the normal at the point of incidence will lie on the same plane. So I hope we are clear till here. So now let us come to the type of mirrors. Mirrors can be plane mirrors, the ones which you have in your homes, right? Where you can stand and look at the mirror and see how beautiful you look or how handsome you look, right? But this picture is definitely not a good one. So this is a plane mirror. And then in some of the amusement parks or when you see the driving mirror, the mirror in your vehicles, the rear view mirrors, you will see that the mirrors are slightly bulged outwards or in some places they are bulged inwards. So these are called spherical mirrors. Why spherical mirrors? Because if we see, these mirrors are actually a part of a bigger sphere from which they have been cut out. So that is why as they are a part of a sphere, so they are known as a spherical mirror. Now again, spherical mirrors will be of two types. Are of two types. First, a convex mirror, and second, a concave mirror. Now, many of the students, even I, at one point of time, always had the confusion that this is convex or concave, or this is convex or concave. So, I'll give you a small trick how to remember. So, remember, concave, cave. So, you have to go inside a cave, right? Whenever there's a cave, you have to enter the cave. So, similarly, remember that whenever there's a mirror which is bulging inwards, means you have to enter or you have to go in. So this is a concave because the light ray is going inside, and the reverse will be convex, which is bulging outwards. So I hope now you will not have a confusion which is a convex mirror and which is a concave mirror. So convex mirror will be bulging outwards always, and concave mirror will be bulging inwards. Now that we have understood the types of spherical mirrors, convex and concave, so now let us have a look at the various parts of the mirror, the various nomenclatures associated with the mirror, which will be required further when we learn about ray diagrams and image formation. So let's have a look. So this is a convex or concave because it is bulging outwards. Remember, this surface, the silvered surface, will be the inner portion of the mirror, which is not facing you. Always remember. So which side is facing you? This side. And this side is bulging outwards. So this will be a convex mirror. Similarly, this. So which side will be facing you? Obviously, the non-silvered side. That is this side. And this side is bulging inwards. So this will be a concave mirror. Yep. So now, as I had told you, these spherical mirrors are called by the name because they are a part of a bigger imaginary sphere. It seems that we have cut them out from the sphere. So now, let us have a look. So obviously, if the mirror is a part of a sphere, then the sphere must have a particular center. This point or this center is known as the center of curvature. Curvature. Similarly, the concave mirror will also be a part of a sphere, of an imaginary sphere. And this sphere will also have a particular center, which will be called as the center of curvature. Okay. Next step, we will draw a line which runs exactly through the middle of the mirror. Through the middle of the mirror. Similarly, we'll draw a line here also. Right? So the point at which this line cuts the mirror, or we can say the midpoint, the exact midpoint of the mirror, of the spherical mirror. This will be known as the pole of the mirror. Similarly here, the exact midpoint of the mirror surface, mind it, of the mirror surface is called the pole. We can denote pole by the letter P. We can denote center of curvature by the letter C. Now, similarly, this circle or the sphere, I would say, will have a particular radius. Every circular object has to have a radius, right? So this radius will be called the radius of curvature. Similarly, here we'll have the radius of curvature. Now, exactly midway between the center of curvature and the pole, we have a particular point, which is called the focus. Now, why it is called the focus, I'll be talking about it after, after some time, why we call it as the focus. But for now, you just need to know that center of curvature and pole, the exact point midway between the center of curvature and the pole of the mirror is called the focus. Similarly, for convex mirror too, pole and center of curvature, the point exactly midway will be called the focus. And the surface of the mirror, of the actual mirror, I'm not talking about the sphere, the actual mirror, it is known as the aperture. Similarly here, this will be called as the aperture. And always remember, just like we had two laws of reflection, we have a particular assumption when we talk about spherical mirrors. And that assumption is that the aperture of the mirror is very, very, very small compared to the radius of curvature. The aperture of the mirror is very, very small compared to the radius of curvature. So once again, we shall recapitulate. So we have a spherical mirror here where this point, where this surface is silvered and the reflecting surface is bulging outwards. So it is a convex mirror. Similarly, here we have another spherical mirror where the silver surface is lying out and the reflecting surface is bulging inwards. So that is a concave mirror. Remember the trick which I told you? Now, both the mirrors will be a part of a sphere. Both the mirrors are part of a sphere, right? And that sphere will have a center. That center will be known as the center of curvature. Center of curvature. Similarly, now if we draw a line which passes exactly through the midpoint of the mirror, through the midpoint of the mirror, the point at which this line will intersect with the surface of the mirror is called the pole of the mirror. So we have the pole of the mirror, denoted by the letter P. Next up, the sphere will be having a particular radius. So the radius of the sphere will be called as the radius of curvature. And the point exactly midway between the center of curvature and the pole is called the focus, denoted by the letter F. Denoted by the letter F. The entire surface of the mirror is known as the aperture. And one more thing which I did not mention, that is this line which we had drawn, which runs through the pole, is known as the principal axis. Similarly here, this line will be known as the principal axis. And again, we learned about a particular assumption which tells us that the aperture of the mirror is considered to be much, much smaller than the radius of curvature. Only then our ray diagrams will hold true, right? And second assumption is that the radius of curvature r is equal to twice the focal length. Now, what is focal length? Focal length is the distance between the pole P and the focus F. So this will be known as the focal length. Similarly here, the distance between the pole and the focus will be known as the focal length F, denoted by small f. So R is equal to 2f. So we have got two assumptions. So whenever you are making a ray diagram for your exam paper or for your answer sheet, always remember to mention these two assumptions, that the aperture of the mirror is much, much, much smaller compared to the radius of curvature. And secondly, the radius of curvature is twice the focal length. Radius of curvature is equal to 2 into focal length. So I hope that we have been able to learn something today, progress something today. And if you find the video to be informative, if you have found my teaching method to be informative, which has helped you understand something, I would request you to kindly mention in the comments if you want the upcoming parts of this chapter, so that I can make the video and upload it for your benefit. And a request, please do like, share, and subscribe to the channel. Thank you.